Hi, Andrew and me Yash are proud to present donation matchmaking, specifically for the classrooms in the United States. As the Tibetan proverb goes, a child without education is like a bird without wings. The big problem here is that 94% of the classrooms don't have adequate amount of funds. Teachers spend over $1 billion every year and still can't manage the education that many of these children deserve due to the lack of funds in the classrooms. So how can we help? Well, there are organizations like DonorsChoose.org that raise and fund many of these underfunded classrooms. So we, as machine learning students, can implement a model which recommends these donations to previous donors so we can increase the amount of donations and hopefully help some underfunded classrooms. The dataset we will be using is a publicly available one from DonorsChoose.org. The dataset has 6 files and you can see the unique values, the features and the size in the table below. The detail of the approach shows that we will be using k-nearest neighbor as our main algorithm. We will divide our approaches into 3 approaches with the help of k-nearest neighbors. The first one will be collaborative filtering, which will suggest donation based by comparing donors to prior donors based on their donation history. We will also be doing content filtering, which will suggest donations by comparing projects a donor has previously donated to similar projects. And then we will use a hybrid approach that will combine the 2 approaches by using a relevance metric. We will explore the details of these approaches later. So let's see what progress and what results have we found yet. So before the training, there's a lot to do actually. We have to merge the data, we have to clean the data, we have to scale the data. We also have to do the test train split, and finally, the dimensionality reduction. Since the dataset was previously split in 6 files, merging them correctly is very important. There's not a single ID that unites them all perfectly, and files like school often correspond to multiple donations, projects, and teachers. Therefore, merging them properly is incredibly hard. After merging the data, we will have 2 datasets. One dataset will have donors as a row, and the other will have projects as a row, which we will use for content-based filtering. Now let's move on to test train split. We created a test train split with the ratio 30:70, and to create the labels for test, we took 20% of the donations as labels instead of features. Those features will have a default value of 0 instead of 1, which will simulate the donor's past self as if they have never donated to the project before. If a donor would have 0 donations, then his only donation will be taken as his label and his features will be all set to 0 for the donations. So let's move on to data cleaning and scaling. A standard scaling was used for numerical data to scale them appropriately, which is incredibly important for k-nearest neighbor especially. The missing day values were handled by filling them with 0 or the mean depending on the feature. So now we come to dimensionality reduction. As mentioned in the paper shown in the presentation, most dimensionality reduction methods result in more accurate classifiers than what is obtained from using the raw attributes for k-nearest neighbor, since it decreases overfitting and decreases variance. Moreover, dimensionality reduction will help with the time complexity since the data sample is really big and k-nearest neighbor is a slow algorithm. The dimensionality reduction was done as to keep the variance at 95%. So, after all that, we move on to the testing and training aspects of the program. So, here is content-based filtering. In this method, we found projects which are the most similar to the ones the user is using. For this, we create a table with probability associated for each project against another. To achieve this, we loop over all the projects. For each project, we train a KNN using the dataset with projects as rows. We do not include projects we are currently finding the k-nearest neighbors for. The label is simply the project ID for the project since every project is its own category. The probabilities of every project from k-nearest neighbors are then stored. Then, during the testing to give recommendations, we plan to simply recommend the sum of the top probabilities for the projects that the user hasn't donated to. Now let's move on to collaborative filtering. In collaborative filtering approach, we plan to find the users most similar to the user we are currently recommending to. Then we can recommend the similar user's donation to the first user. This will be done by training a KNN for the dataset with donors as row for every donor. During test, we will list most similar users using the trained KNN. We will use their donation list to see which projects has donated to by the most similar users. In this manner, we will create a ranking of the projects. So, what will we implement next? We are going to hypertrain the KNN parameters. K needs to be hypertrained for both of the KNN that are being used. To do that, we must implement cross-fold validation. We can't use the test data to hypertrain and evaluate the model. Therefore, we need an additional way to evaluate for hypertraining. Lastly, one of the main things about the algorithm is the hybrid approach that merges the results from the 2 approaches. Therefore, we must implement that and then we must hypertrain the weights associated with the hybrid approach. So hopefully with our project, we can contribute in little ways towards this big issue that we face. Thank you so much.